Hello everyone, I am Ritesh Singla. Today we will start our core course, Real Analysis. So first of all, let me give you a brief introduction about myself. So my name is Ritesh Singla. I have done my undergraduation from University of Delhi. My post-graduation in mathematics is from Tata Institute of Fundamental Research, Center for Applicable Mathematics, Bangalore. And my PhD, I am pursuing my PhD from IIT Delhi. In coming 3 or 4 months, I will submit my thesis. And apart from this, I have some awards and academic achievements, which are scoring rank 14 in IIT-JAM 2016, rank 63 in GATE 2018, and TIFR from 2016 to 2018. Apart from that, I have also cleared my NET exam, CSIR-NET with JRF. Course Real Analysis, we will be using 4 books. So we will be using only standard. These books will be available on our Telegram channel as well as on our Google Drive channel. The link of both the channels will be in the description. So the first book will be Introduction to Real Analysis by Bartle and Sherbert. So it is a very well known and well written book. So from this book we will be mainly focusing about the sequences of real numbers, functions on R. In functions we will talk about limit, continuity. In continuity, of course, uniform continuity, and then in differentiability. Written by Charles, sorry, Charles G. Denlinger. So from this book we will mainly be focusing on the series part. So convergence and divergence of infinite series, and secondly again series of function, right? Then there is the third book, which is elementary analysis by K. Rose. So in this we will be dealing with the Riemann and Darboux integral, and also our improper integral. After that, the only thing which is left is our metric space. So for that we will be following metric spaces by Shirali Satish and H.C. Vasudev. So from this book we will only be dealing with the metric spaces. So these are the 4 books which we will be following in this core course. And so the plan will be like, first of all, we will start with sequence. The convergence of sequence, different theorems on sequences. Then we will move to infinite series. Then we will move to functions, that limit plus continuity. Then we will move to differentiation of the functions. After that, we will move to the integration. Then sequence and series of functions. And after that, at last, we will talk about matrix space. So this will be the draft on how we will proceed on this course. Now, first of all, books, as I've already told you, books will be available on the Telegram channel as well on the Google Drive link. And we will have 3 lectures a week, one on Friday, Monday, and third on Wednesday. In those 2 lectures, Friday and Monday, we will learn about new topic. And on this lecture on Wednesday, we will do some problems related to previous 2 lectures. Also, if you have any kind of query, you can directly ask on on the Telegram channel. So there also, if we have seen any good problem, those problems asked on Telegram channel will also be discussed on Wednesday. And apart from that, the class notes, so you don't need to worry about writing, but whatever I'm teaching you here, you don't need to worry about writing it. The PDF of all the material will be again uploaded on our Telegram channel. So PDF will be available on our Telegram channel. But see, there is no point of reading the PDF directly if you are not watching the channel, because everything is written in the book already. So you are here to understand the topics, right? So you have to take the lectures first, then only the PDF will make sense to you. And last but not the least, if you like our lectures, please subscribe to our YouTube channel, like these videos, comment your reviews and suggestions, and please do share these videos with other friends. So with this note, we will begin our today's lecture. Today we will talk about finite, infinite sets. So I assume that every one of you know what is set, what is relation, what is functions. This is elementary class 11th mathematics. So we will directly start with finite and infinite sets. So in infinite, we will see 2 kind of set: countably infinite, which is also known as denumerable sets and uncountable. With the definition first. So finite set, so by S is said to be finite if there exists a bijection between S and some subset of natural numbers. Fine. So it is a very basic definition. The main definition is about the infinite set. Infinite sets. So sets which are not finite are infinite. Sets which are not finite are infinite sets. So in that, first of all, we will discuss about countably infinite, which is also known as denumerable set. So what do we mean by countably infinite? So a set is said to be countably infinite if there exists a bijection between the set and the set of natural numbers. A set S is said to be countably infinite if there exists a bijection between S and set of natural numbers. Fine. So see, there is a difference in the definition. When we were writing about finite set, we said there exists a bijection between S and some subset, right? See, we have written here some subset of set of natural number, and in the definition of countable infinite, we are writing directly a bijection between S and set of natural numbers. Okay, so this is the definition. So there is nothing to explain about the definition are self explainable. And then we have uncountable set, and n cross n. So all of these are countably infinite set. What is uncountable set? A set which is not countable is known as uncountable. For example, set of real numbers. So we will discuss this why set of integers and set of rational numbers are countable and why set of real numbers are uncountable. For the time being, these are the definitions. Okay. So let us proceed further now. What it says is there is some theorem. It is a very trivial theorem. You can just feel it. A set, okay, for a set S, all of these statements are equivalent. First statement is S is countable. Second statement is there exists a surjection. Surjection means onto map, right? There exists a surjection between set of natural numbers n and set S. And third, there exists an injection. Injection means one-to-one map. Injection between set S and set of natural numbers. So what it is saying, if I am saying that S is countable, it is equivalent to say that there exists a surjection map. So phi from N to S is a surjection. Then we can say that S is countable. Similarly, if there exists some map xi from S to N such that xi is injective. Okay, so this is very trivial statement. You can do it by definition only. Since first of all assume that S is countable. So we know that if S is countable, there exists a bijection between and N and S. Say that bijection to be delta. So if delta is a bijection between N and S, then delta is a surjective map between N and S. So we are through that one implies two. Fine. Similarly, if there exists an onto map from, okay, let us do this proof. I am doing this proof for general case. Let A and B be given two sets. And phi defined from A to B is onto. Then we know that there exists some phi inverse from B to A, which will be 1 to 1. Of course, finding those equivalence classes, and then only we can say that if there exists a onto map from a set A to set B, then there will exist an inverse map, or I should write this map as some xi from this phi. Then we can define xi as 1 comma 2 going to 2 4 6 as 1 is going to 2 and 2 is going to 4. We can't really write 2 is going to 6 because in order to define something as a function, so every pre-image has only one image. So but this is also a function, 1 is going to 2 and 2 is going to 4. Fine. So it will be a one-to-one function which we have drawn from an onto function. So that is why all of these statements are equivalent. Numbers are countable. First of all, we will discuss about this. Secondly, we will discuss about Cantor set. Cantor set, and if you like this video, please do join our channel, subscribe to our channel and join our Telegram channel. Thank you.